Good Maher with Risk Management Professionals, and I'd like to welcome you to our RMP's continuing Offshore Facility SEMS webinar series. And today we're going to be broadcasting from our project office in Houston. And what I'd like to do is focus on a paper that'll be given at the Global Congress on Process Safety next week in Chicago called Paradigm Shift in the Regulatory Applicability of Safety Management Systems to Offshore Facilities. It's a mouthful, but what we're going to be focusing on is basically the SEMS program, how that relates to other programs that are out there, and effective mechanisms and tips for implementation. Before we get started, just a couple of logistics. We do have all the attendees on mute. We are using a WebEx conferencing interface. The attendees are on mute during the course of the presentation to avoid paper shuffling, other noises, and distractions from interrupting the rest of the folks who are trying to listen. At any time, if you do have some issues or concerns or technical problems, please feel free to call the number on the screen, 877-532-0806, or use the chat window to contact our webcast producer, Solveig Sather, directly. During the course of the presentation, again, you'll be on mute. However, at the end, there'll be plenty of time for question and answer. We're going to open up to questions, and you can use the chat interface, or you can have audio link it in if you'd like to make some comments or add to things for all the different participants. Something else, too, with respect to the use of your screen controls, the presentation sizing is set so that you can read everything. However, the video in the upper right-hand corner, which is basically my image, you can expand or contract to suit your needs and make things comfortable for you. So I guess let's take a look at our key topics. What I'd like to do over the next 60 minutes or so is review driving forces for the evolution of the regulatory requirements, looking at the different regulations, drawing parallels between onshore and offshore regulation development, and also looking out at how the technology's evolved along with the regulations over the years. And what I hope to do is put together a mosaic for how all these things fit together and why they work the way they do and why they're structured in such a way. A lot of folks in the offshore industry right now, with the November 15th deadline coming up, are basically going, why me? Why do I have to do this? Well, there's a lot of history to that, and there's a lot of good reasons for sensible applications of safety management systems for offshore facilities. And what I'd like to do is compare those requirements to other regulations that are out there. And with those parallels, I really hope to provide some tips towards effective implementation and going into how to make the overall program very effective. And of course, I'll be opening up for question and answer. Next. Okay, and actually let's go to the next item too. Okay, what I'd like to focus on are make the audience understand what's been happening and why, and contrast the different regulatory requirements, and also to suggest some effective approaches for implementation. Next. The key events in 2010 that have kind of driven this, 2010 started with a very positive outlook on offshore facilities and offshore facility safety. And in fact, on March 31st, the President provided, in his speech, announced the expansion of offshore oil and gas exploration just weeks before the tragedy associated with the Deepwater Horizon accident, which resulted in 11 fatalities, 17 injuries, and over 4 million barrels of oil released in the Gulf of Mexico. Okay, there's a restructuring order that there was a fresh look at the Minerals Management Service and all the things that were done, and that was done in May, and the MMS was restructured in May. Moratorium was put into place, and basically throughout the course of the year, there was pretty much a downward spiral towards a very negative attitude, which is how the year ended, towards offshore oil and gas exploration in the Gulf of Mexico. And in fact, on October 15th, it was promulgated 30 CFR Part 250, which is basically the SEMS requirements. If you need to know, I'm not planning to review all the different aspects of the regulation or all the background. If you do need some more information, and there are some references towards the end of this presentation too, www.sems1.com is a good reference. It provides copies of the regulations and also links to all our SEMS Offshore webinar series that provides a lot of background and other tips. Next. So what I'd like to do is start by discussing what causes accidents and the types of regulations that are effective for addressing those different causes. Next. Accident causes and performance indicators. Incidents are rarely caused by just a single catastrophic failure, but usually by multiple events or failures that coincide. There's a Swiss cheese model, a spinning disk model, that have been very useful for helping to describe this. Typically, hazards are contained by multiple protective barriers, and the whole idea is that there's weaknesses or holes in these barriers, and it's when the holes align that the barriers are neutralized, and then you can have an accident. That's one visualization for how you can do that, and it describes very well process safety type events, which typically tend to be very catastrophic, and also tend to have multiple events happening at once that result in those consequences. The other aspect of that is different. The other safety measures is personnel safety. Those typically are more direct types of events. So let's contrast the two. Next. So general types of offshore facility risks that people need to be aware of are personal safety and process safety, as I mentioned. To contrast the two, consequence measures for personal safety are usually done in terms of lost time injuries, whereas for process safety, these can be serious injuries, financial impacts, environmental, even fatalities. For personal safety issues, key control measures include design, PPE, and also attentiveness to job activities. Controls for process safety, people have gravitated towards safety management systems. That's the SEMS acronym that I use pretty frequently during this presentation, and I'll be describing why those are good control measures for process safety type events. For personal safety, regulatory mechanisms that are very effective are prescriptive safety requirements typically address personal safety issues pretty well, but for process safety, performance-based safety requirements are typically more effective. Next. So there is a lot of overlap between personal safety and also process safety. However, there are some significant differences. If you look at an offshore facility, slips, trips, and falls, comparing them to major accidents, there's a pretty limited correlation between the number of slips, trips, and falls type events to the number of major accidents. So again, although there's some overlap between the different types of safety, the biggest impacts are, there are significant differences between the two. Next. Prescriptive regulations typically, what are prescriptive and performance-based regulations? Prescriptive typically state what actions and requirements to do, and they're very, very specific in terms of what needs to get done. Goal or performance-based regulations are looking at objectives or the desired outcome and leave the method for achieving those objectives up to the facility operator. Basically, as we discussed before, performance-based regulations are better used for safety management systems types of approaches, and prescriptive regulations are better for personal safety. Next. So what I'd like to do is, for the rest of the discussion, is to focus on the process safety issues and the performance-based regulatory approaches, and then discuss parallels between the onshore and offshore safety management system regulation development. Okay, next. Okay, we already discussed, and I briefly mentioned the Deepwater Horizon event that happened in April 2010. Let's take a look at a couple of other pivotal events that have occurred in history that have had a big impact on process safety and performance-based regulations. The Bhopal, India accident in December 1984 resulted from procedural errors and a reactive chemistry incident that resulted in a large release of methyl isocyanate because it reacted exothermically with water. This exothermic reaction resulted in a lot of heat, large pressure increase, and challenge of the relief valves and a release through the relief valves. A lot of the control systems were disabled, and also key protection systems were disabled, both of which had occurred without any sort of management of change program implemented, and it resulted in 40 tons of methyl isocyanate release into the community and almost 4,000 lives lost, and over 100,000 permanent injuries. It was considered a very pivotal event because not only by the nature or magnitude of the tragedy, but also with respect to people taking a fresh look at performance-based regulations and safety management systems. And I'll be talking more about that in a few minutes. Next. The Piper Alpha platform tragedy in 1988 was a result of a work permit system that wasn't being implemented properly. A spare pump relief valve was out for maintenance. The opening was left unblinded. There was a startup of the pump and also significant vapor release, explosion fire, and 167 lives lost. Just as Bhopal, India was a wake-up call for the need for safety management systems implementation at highly hazardous facilities that resulted in guidelines from the AICHE, guidelines from the API, and also regulations from OSHA and EPA in the United States. The Piper Alpha platform disaster really raised the issue for offshore facilities, and a lot of it because of its location resulted in a requirement for safety cases in the United Kingdom. Next. So for all those events, Piper Alpha, Bhopal, India, it was very clear that major accidents have caused a significant loss of life and property and a lot of other significant costs. Business interruption, lost confidence in contracts, increased regulation. And so it was clear that there was a need by industry and a real driving force by industry to go through and make sure that there's a proper management system implemented to control these types of events. Typical characteristics of major accidents are that there's usually relatively simple precursors. It's not some unknown technical issue, but basically a combination of things like the spinning disk and Swiss cheese models of little weaknesses that have aligned coincidentally at the wrong time to result in a significant accident. Well, root causes are a failure to maintain the design intent, making sure that design limits were upheld, and also that those holes in the Swiss cheese or the spinning disk don't line up, resulting in a significant accident. So the overall conclusion, and this was known back in the 80s, and perhaps even before that by people who are very knowledgeable in these types of issues, were that the most effective mechanism for improvements were really not by addressing specific actions, but by affecting changes in the way business is done, basically safety culture and management systems. So that's where the whole concept of management systems came about, that resulted in guidelines from AICHE, API, the eventual promulgation of process safety management and risk management programs, and now for offshore facilities in the United States, we have the SEMS program. So let's take a little look at the overall timeline to kind of weave this together. Bhopal, India, as I just mentioned, happened, next please, happened in December 1984. And it was very quickly after that, in 1985, that the Center for Chemical Process Safety was formed, and the Technical Steering Committee, I had the privilege of serving on that for several years in the mid-'80s, was formed. And one of the first things they did is they recognized this need for control of safety management systems and having an appropriate control factors put in. And in 1987, they put out guidance for technical management of process safety. This was a good guidance document put out by the CCPS, which was an element of AICHE. In 1990, the API put out Recommended Practice 750. Just a few years later, using much of the same concepts, but focused more on the petroleum industry. These were initiatives initially taken by industry and, in general, very effective, but their application was optional. So to provide consistency and to avoid a situation where a company that did not want to go through and properly address these requirements so that everybody had an even basis from a competitive perspective, and for applying appropriate levels of safety, OSHA promulgated Process Safety Management in 1992, and EPA promulgated Risk Management Programs in 1996. All these, for onshore facilities, were driven by events that occurred in the 70s and 80s, the pivotal event being Bhopal, India in December 1984. The important things to recognize are the fact that industry did take an initiative first, and the regulations that came out afterwards closely paralleled what the industry guidelines were, with, of course, some differences, but there are more similarities than differences. So that's the top arrow, and that covers the onshore facility applications and leading to the regulatory environment that we've got now for safety management systems. The middle arrow deals with offshore safety management systems in the United States. There is a lot of interest in the 80s and 90s for making sure that companies that have large investments in offshore facilities properly put in safety systems that would provide protection and have effective application of safety management systems. In 1990, the Platform Safety Shutdown System Effectiveness Study, I'll tell you more about that in a few minutes, took a fresh look at the new developments in electronics, voting logic, and a lot of the things that you could do with the evolving control and protection technologies, and weave that in to provide a balanced level of safety for offshore facilities. Just as the industry took action for United States onshore facilities, for offshore facilities, the SEMS concept was produced in 1991 as a result of one of the reasons being the tragedy with Piper Alpha. API Recommended Practice 75 came out of that. It was updated in 2004, and the SEMS concept was put on the table as part of the federal regulations in 2006 with 4 key elements, and we'll talk more about that shortly. The proposed rule had updated in 2009, and the final rule for safety and environmental management systems for offshore facilities for the United States came out in 2010. The arrow at the bottom for offshore safety management systems in the UK, as a result of Piper Alpha, the first safety case requirements came out in 92. It was updated in 2005, and there was some specific cases and specific guidelines issued later on. A key thing to notice is that the firm regulations for offshore facility safety management systems came out in the UK, and a lot of that because Piper Alpha was in UK waters. It was something that was involving companies out there. The United States had put out guidelines, but really never came up with specific regulatory requirements proposed until 2006 and then finalized in 2007. And the final SEMS rule is basically much more complete than the earlier concepts put forth in 2006 and 2009. So what do we glean from all this? First of all, the driving force of these regulations, a lot of it was reactive. People looking at accidents that occurred and what you should do about that. In all cases, well, in most cases, industry took the first response to develop guidelines, and the regulations that came out afterwards were pretty much an emulation of a lot of the guidelines that industry had put together. For example, the SEMS final rule in 2010 makes heavy reference to API Recommended Practice 75. Another key observation here is throughout this entire time period, from the mid-'80s to current day, a lot of the details and specifics for developing safety management systems and the various elements, whether it's an onshore facility, a wide range of technology applications, whether it be offshore facilities and a wide range of applications for offshore, a lot of the different elements are very common from all these. So thousands of people have looked at these and really come up with the elements that are part of PSM, RMP, and SEMS as being paramount towards the implementation of safety as part of safety management systems at a whole lot of different types of facilities. Okay, next. What I'd like to do is, where this goes to is, what's the environment right now? Well, in March 2011, you've got a wide range of applications. SEMS making heavy use of references to SEMP with a lot of the key safety management system elements that are very familiar to folks who've implemented PSM and RMP. These are management system elements. There's not a lot of detailed calculations and other types of requirements. It's basically managing the level of safety at your facility. Typically, they're a lot less effort than areas or parts of the world where specific safety cases are required. Safety cases also have to do safety management systems as well as risk assessment and quantifying that. So the SEMS programs, basically less effort, and safety cases provide you a little bit more insight. But for the United States right now, the application of SEMS is pretty well balanced, and at this point, there's not a major drive towards the implementation of safety cases. And so that's how it fits in the overall framework. What I'd like to do next slide please, is look at take a broad look at the regulatory programs and the importance of protection system design in evaluating risk. So next please. The first thing to do, next slide please. The first thing to do is look at the interdependency of technology, risk, and regulation. Basically, the inherent risk of offshore drilling in various platforms drives the need for safety instrumented system, various levels of design, and the reliability associated with that. Then also, by those designs and those additional protective features with the inherent reliability feed the ability to have more complex and dealing with facilities that are potentially more hazardous. When you're looking at more high hazards, more complex protection systems, the various facility risk analysis techniques also need to be bumped up. And so basically you've got a whole cycle of the technology, safety systems, matching the types of hazards associated with various facilities, and that includes offshore. Okay, next. To get a good understanding of this, it's important to understand the big picture. Basically, safety management systems and managing safety at offshore facilities is all about understanding risks. Understanding risks means understanding likelihood and understanding the severity of all the various events that can lead to and build into your risk at a various facility. Understanding those, just looking at the likelihood, doesn't tell you a whole lot. You can have a highly likely scenario with very low consequences that's not very important. Just looking at the consequences doesn't tell you a whole lot. A very high consequence event that really is not possible, really there's not much you're going to do about that, so that doesn't tell you a lot either. So it's really balancing the likelihood and the severity that gives you the insights that help you manage the safety at a facility and understand if there are weaknesses that need to be addressed and improved upon. So this is the whole foundation for looking at your facility and applying the various management systems and what level of technology you need for controlling risk at that facility, the different levels of protection features, etc. And next. So that provides an overall framework. And the thing to keep in mind is that as we develop technology further, if we're trying to keep risk constant and we're looking at more and more hazardous facilities, then really you've got to decrease the scenario likelihood. If you want to lower risk over time, and if you're looking at consequences that are increasing because you're dealing, potential consequences that are increasing because you're dealing with more highly hazardous facilities, then you've got to decrease the scenario likelihood even further. So this whole idea of the protection system design and reliability is basically an integral part of maintaining risk at the levels that are acceptable for your situation, for your operations, and for your company. And so what does this mean for safety system reliability for events that can have large personal consequences, large environmental consequences, or large impacts on ports, harbors, or shipping? Okay, now going back to our different designs of basic process control systems, safety instrumented systems, and high integrity protection systems, there's been a lot of evolution over time. And even now there's a very wide range of, oh, I'm sorry, next slide please. There's a very wide range of implementation at various facilities. Some older facilities or even some newer designs with simple processes can use analog devices, very simple types of control and protection systems that have a low cost associated with them. And if they're tried and true, good reliability associated with that. As you're dealing with more highly hazardous processes and you're having more complex systems, you're applying, and this has been an evolution of these electronics and other devices available for control and protection systems, increased redundancy, higher pedigree devices, increased diversity, applying voting logic, and there's a whole science behind the application of instrumentation to match the level of risk at a facility and the specific scenarios that are involved. And at the top of the screen in the arrow, you'll also see some references to ANSI and ISA standards that help drive that. So there's been an evolution of this over time, and as I mentioned before, the hazard analysis, the kind of management systems in place, and the types of designs that you apply at the plant site really emulate that and have evolved along with that. So the regulations, the facility design, and the analysis techniques kind of need to keep pace with each other. Next, please. As I mentioned before, one of the key pivotal events for offshore facility safety systems, as we're going from simple analog devices into more advanced electronics and the application of intrinsically safe electronics, was in 1990 when we did the process safety shutdown system effectiveness study. This was done, I had the privilege of being involved with this, and this was done for a variety of platform types, very complex in Stratfjord, medium complexity in the Gulf of Mexico, Green Canyon, and also in very low complexity off in Nigeria, taking a look at what systems were out there, where electronics was going, looking at a wide range of protection system applications from pneumatic to electronic, and looking at what was really dominating that. And the same kind of findings that we found back in 1990 really apply today too. With the appropriate logic processing units or electronics, whatever voting logic is appropriate for the level of safety that you need, still the end devices and also the actuation signals and the transmitters tend to drive this. So these types of conclusions are important to keep in mind and have been a mainstay all throughout this evolution of various control and protection features. Next, please. All right, and this slide is really just meant to kind of pull that all together, looking at the evolution of the protection system design, the reliability criteria and design architecture specifications for the systems that are out there. And over the past few years, there have been more and more application based on those ANSI and ISA standards of various safety integrity levels that you'll want to apply to achieve the reliability that you need for the protection system. So as I mentioned, the design, the types of hazards, and the types of analysis techniques have kept pace with each other, and that's also what you're seeing from a regulatory perspective too. Today you're going to be looking at the implementation of safety and environmental management systems as part of 30 CFR Part 250, but as we go more and more into deeper waters, more highly hazardous situations, you're going to see that the previous bar with the complexity of the regulations also going up to meet that, and probably at some point in the United States, probably not for quite a few years, the application of safety cases will be a requirement for offshore facilities. But that's not a requirement now, so we're going to be focusing on safety and environmental management systems. Next. So as a reminder, as we develop the technology more and if we're keeping risk constant and if your potential consequences are increasing, you've got to decrease scenario likelihood. How do you do that? Basically control and protection systems in terms of design and also management systems in terms of how you operate it. So this feeds right back into your design guidelines, redundancy, and diversity, what kind of design configurations that you've got, protection system reliability, and also the mechanical integrity program that you put into place to make sure that you're evaluating, you're maintaining the reliability of these protection features where they should be. It's important to remember limitations of prescriptive standards. With all the different designs that are out there, with the changing paradigm of what's an acceptable risk threshold, with the lessons that all the folks in the offshore industry have learned after Deepwater Horizon in terms of the potential consequences and potential impact on business, it's very clear that prescriptive standards just can't cut it. That's why you need performance-based standards and the mechanisms to adjust the detail, the type of implementation based on the specific facility. Okay, next. So given the fact that safety management systems are out there and they're really here to stay and there's a good reason for them, what I'd like to do is take a little bit of time and show you the universe of what's out there with respect to safety management systems and give you some definitive tips of how to link SEMS to your other programs, hopefully save you some effort. Next. First of all, let's make sure we're clear on what SEMS is all about. The Safety and Environmental Management Systems requirements from 30 CFR Part 250 basically include all the key elements on your screen. Going clockwise, safety and environmental information, which is a core part of understanding your design and being able to communicate key safety issues. Hazards analysis, also understanding the potential hazards so you can correlate that and have a platform for identifying potential weaknesses at the offshore facility. Management of change. A lot of major industrial accidents have occurred because people have made changes without really evaluating the total potential impact of that change. Operating procedures, basically being able to operate it safely, safe work practices, training programs to make sure your operators out there understand potential hazards and how to operate it to prevent accidents from occurring. Mechanical integrity, pre-startup reviews, emergency response and control, incident investigation, and auditing, and records and documentation. The four in red, they're red for two reasons. Number one, those are the four elements that in 2006 were highlighted as part of the initial SEMS rule as being the most important ones to implement first, importance gauged by accidents that have occurred in industry, and also what the MMS wanted to regulate. The accidents have occurred, and a lot of citations have been issued for deficiencies in various programs. Hazards analysis, MOC, operating procedures, and mechanical integrity have been key parts of that. The other key, there's a lot of, some of these other elements too that deserve a lot of attention for SEMS, and we'll go into that in a few minutes. Next. Okay, so this is a, maybe it's a little complicated, but it's meant to illustrate the area in green is the overlap between the key programs that we've been talking about. Safety and Environmental Management Systems, Safety and Environmental Management Programs, SEMS being the name of the program put forth by API Recommended Practice 75, SEMS being the current regulatory standard, and process safety and also process safety management and also risk management programs. The majority of the effort, the majority of the elements are, for all practical purposes, identical. There are all the differences between the various implementations of the standards for the area in green are relatively minor. But these minor differences also, as long as you're aware of them, you can make good use of that to help coordinate and consolidate your programs. One of the other things, a key thing to point out here is over the years as process safety management and risk management programs have evolved, it's been 19 years since PSM was promulgated. It's been 24 years since the AICHE CCPS guidebook came out. And from that initial guidebook, even though there were a couple of less elements to the current applications of PSM, RMP, and SEMS, you're not looking at major differences in strategy or philosophy. In fact, there's more in common than not. Thousands of professionals have been looking at these programs and looking at ways to streamline and to improve it, and the elements are still common, and it's really not a coincidence that people look at that as your key elements and things that you want to implement to have a safe facility. Now again, back to the performance-based standards. How you implement it, exactly what you do, is not specified by regulation. You need to make a decision on the mechanism for implementation and what is effective at your facility. And of course, be able to justify that should it be looked at by the regulatory authority. Next. Okay, so let's, this is just hopefully a handy table with regulatory citations for the different elements using the terms as identified in the SEMS requirements. The column in the middle there is twofold. It's the API Recommended Practice 75 and the specific section number, and also the specific section number for 30 CFR Part 250. The concept of Recommended Practice 75, which pretty much synchronized with other programs at the time, was adopted at length by the current SEMS requirements. And I'm also providing you with citations for the OSHA, PSM requirements, and EPA. So EPA is 40 CFR Part 68, and OSHA is 29 CFR 1910.119. So hopefully this is a handy table. Where I'm going with this, it'll be clear in a few minutes. If you're a company that has business units onshore and offshore, this can help communicate and maybe help develop standard procedures rather than reinventing the wheel. Okay, next. Okay, what I'd like to do is, I hope this is really handy information, and I'm going to go through it fairly quickly and only hit the highlights. What I'd encourage you to do, and if you don't already have a copy of this, I'll make sure that a copy gets sent to all the participants. The paper that was written for the Global Congress next week actually has a lot more information and a lot more details contrasting these two. And my main interest is showing you what the differences are from the SEMS program to PSM and RMP so that you can make use of resources in your company, hopefully save you some time and effort, and make things a little bit easier to implement at your facility and throughout your company. So if you look at safety and environmental information, all the different process flow diagrams, block diagrams, P&IDs, electrical area classifications, platform layouts, siting layout information, etc., the actual differences conceptually between what you're being asked to do between these offshore and onshore programs is very minimal. If you have a good handle on what needs to get done for onshore facilities, you can apply that to offshore. For hazards analysis, there are some key differences. And in fact, if you look, the poster that we're presenting at the GCPS actually has this one in red. Hazards analysis and auditing are the two biggest differences, and I'll go over auditing in a few minutes. For hazards analysis, for PSM and RMP, there's basically just use of standard techniques that are either defensible, something that you like to do in your company, or use standard approaches as defined by the various guidebooks that are out there. PSM and RMP basically say do your process hazard analysis initially prior to facility startup, and then a revalidation every 5 years. And there's a lot of intricacies for revalidation in these various techniques. If you need a lot more information on this, please look at our website or tune into one of our webinars on the HAZOP study approach and the nuances and techniques for doing that efficiently. For the SEMS program, quite a bit different. You need to do an initial hazards analysis by your November 15th deadline, and also update it at 3-year intervals starting on the 2nd year after initial SEMS program completion. I think the intent here is not to make everybody make sure they keep their calendar up to date and watch this carefully. I think the intention is that after you do the initial hazards analysis, and you want to do one a little sooner than 3 years, so they pick 2 years. But then after that, after you've done a fresh eyes review at 2 years, then a 3-year interval for looking at these things is appropriate for facilities like a lot of offshore facilities that don't change a lot. Face it, for offshore facilities, making changes, adding new equipment, making changes to design, there's a lot of complications because of limited space at the platform. A lot of times you've got to remove equipment or remove vessels to install something new. So there's because of the cost increase for making changes, they tend to be a little bit more static in terms of their design. In contrast, onshore facilities can be changed a lot more often. They've got a lot more flexibility. And so they're anticipating that for offshore facilities, you really your hazards analysis over time shouldn't be changing all that much. One of the key differences for offshore facilities in these SEMS requirements are a supplemental job safety analysis. It's not just acceptable to do a facility level hazards analysis using a technique like a HAZOP study. You've also got to do JSA to take a better look at operations. And I believe that I would guess that the driving force for that is the fact that a lot of offshore facilities are a little more operations intensive, and they want to make sure that those specific steps get a thorough look-see. Okay, next slide. Okay, going down our list of the key elements, management change, very minimal differences between offshore and onshore regulations. By the way, if you want more details, the paper that we'll send you a copy of has a lot more details in a table at the end of it that provides hopefully a real good basis for you being able to move forward and some tips on how to keep things streamlined. For operating procedures, for SEMS program, there's a requirement for review at the conclusion of specified periods and they don't tell you what that frequency is. The procedures must include the job title and reporting relationship, emergency operations specific to offshore facilities, and that facility needs to be identified. Operating modes associated with bypassing out-of-service equipment must also be specifically addressed. Next slide. Operating procedures also must include impacts to the human and marine environment, and procedure changes must be communicated to potentially affected personnel. Again, recognizing that there's a little more challenge to a lot of offshore facilities because of heavy use of contract personnel. One of the differences for process safety management and risk management programs are a clear requirement for annual review and recertification. The review period for offshore is not specified. Again, performance-based regulations, you need to decide when it's required and put that into your program. Next element, safe work practices, very minimal differences. Next slide. Training. For the SEMS program, there's not specifically a training frequency, but it does because of the characteristics of offshore facilities, recommend the use of drills as an element of the training program. It references API recommended practices for training programs and program details, requires documentation of instructor qualifications, and you also have to make sure that you do training for operating procedure changes, safe work practices, and emergency response and control. SEMS is picking up on the things that are specific to offshore facilities and are things that they've seen as potential deficiencies for other facilities onshore in the past. For PSM and RMP programs, there's a specific training frequency identified, basically refresher training every 3 years. Again, that reflects some knowledge learned over the years and the fact that there are differences between onshore and offshore facilities. Okay, next element is assurance of quality and mechanical integrity. This is a big part of your program. It's a very important part of your program, but it's an important part of all safety management system programs, and so there are minimal differences between PSM, RMP, and SEMS. Pre-startup review, very similar. And in fact, for those of you who are implementers of these various process safety programs, these are linked together in a lot of cases when you're looking at, the pre-startup review is very, very closely linked with management change. Emergency response and control for the SEMS programs. The update requirements aren't specified. However, there are clear requirements for an emergency action plan, designated emergency control centers, and conducting training and drills. Again, recognizing some of the unique characteristics of offshore facilities. For PSM and RMP programs, basically an annual update is considered best practice. Next element is incident investigation. PSM and RMP require the initiation no later than 48 hours following the incident and retaining the incident investigation reports for 5 years. SEMS is a little bit looser, actually, in that it says initiate the investigation as promptly as possible, but they don't give a specific time period. They want the findings retained for use in the next hazards analysis update so that they see that they want that subsumed in by some mechanism and reviewed by your hazards analysis team. You want to also correlate the investigation findings and corrective actions to specific root causes. These are lessons learned from applications that maybe haven't gone so well for onshore facilities or PSM and RMP. And also you want to distribute relevant findings to similar facilities, as well as other affected personnel. Again, a recognition that in the offshore world, there's a lot of facilities that are very similar, so events that occur at one location can have a very widespread application where people can benefit from the sharing of knowledge as a result of these incident investigations. Next slide. The next key element is auditing the SEMS and SEMP program elements. This is a big difference, and this is one I highlighted in red on our GCPS poster board. This element is going to cause a lot of work, and there's a lot of checks and balances here in terms of communicating with BOEM-RE. These audits are required at 3-year intervals starting in the 2nd year after the initial SEMS program completion. Now recognize here's that 3 and 2 period that is synchronized with really the hazards analysis. In fact, they want you to synchronize the hazards analysis with the audits And also, I think a lot of the reasons why they had different time periods for these go back to the discussion we had just a few minutes ago. There's a specific requirement for submitting an audit plan to BOE-MRE within at least 30 days before the audit. That gives them time to review it and validate that you're taking an approach that's acceptable to them, and I'll tell you about that in just a second. You also, after the audit, within 30 days of audit completion, you have to get a report to BOE-MRE. They've noticed in the past that a lot of folks had done the audit, not done a good documentation for a period of time, and they want to speed that up so that BOE-MRE can review that, take a look at the audit results, and take corrective actions on their end as need be. And at the same time that this 30-day clock after the audit completion, the offshore operating company must submit a plan for addressing audit-identified deficiencies. And also, a key thing here is a requirement for a review that's independent of the program and avoiding conflict of interest. It may not be acceptable to have the same person who creates the program also audit it. If you feel that the same person, the same company, the same engineering contractor is doing this, can develop the program and also audit it, that may be acceptable, but you've got to justify to BOE-MRE why it's acceptable and that you've taken steps to avoid conflict of interest. And there's this entire section in subpart S of the 30 CFR Part 250 that deals with auditor qualifications. So this is something that's taken very, very seriously, and it's trying to build on things that are applicable to offshore facilities and also lessons from the past. Next slide. For PSM and RMP programs, audits are done on a triennial basis, a much simpler clock. And even though it's a simpler clock, because it's desynchronized for PSM and RMP with process hazard analysis updates and the submittal update, there have been a lot of snafus where people don't recognize and get their audits done on time. So I believe that's why BOE-MRE is trying to synchronize that, of course, along with the importance of the elements. And for PSM and RMP, there's a requirement to retain the 2 most recent compliance audits. There's also a records and documentation section for SEMS. You've got to keep a copy of the program documents at an onshore location, and also for 6 years, you've got to keep general records and also audits. Next slide. So for 2 years, you've got to keep JSA records, management of change documentation, injury and illness log documentation, contractor safety policy and procedure evaluations, and the records have to be kept orderly, readily identifiable, retrievable, and legible. So I would gauge from this that there's going to be a lot of interest for BOE-MRE personnel to be reviewing their program and working directly with a lot of the offshore facility operators to look at how robust your SEMS program is and how well it's being implemented. For PSM, RMP, there's a lot fewer specific requirements. Just basically it says supporting documentation must be kept for 5 years. Next slide, please. So now we've looked at the evolution of these regulatory requirements and where they're coming from, what they're trying to achieve, why you're doing performance-based requirements, a lot of the technology applications, and the evolution of the analysis techniques over the past couple of decades that emulate technology changes, changes in the level of hazard at facilities, and also, again, linking this to various program elements. So now what I'd like to focus on, since I've contrasted the different programs, I'd like to talk to you about organizing an effective SEMS program. Next. Next slide. Okay, good. So very importantly are business issues, of course. We have to maintain a level of safety, and we also have to make sure that you maintain the business viability of a facility operation. The clock is ticking, and a lot of facilities have to implement their SEMS program by November 15, 2011. For a lot of facilities that have an entrenched culture, that have been part of companies that have had programs that have been provided to them, or things that are very similar to PSM, RMP, or SEMS, there may not be a lot of work to do. Or it may be very easy to just look at the differences that I've been contrasting and morph your program to address those differences. However, there's a lot of facilities out there that really haven't done this in depth and haven't provided a robust program, and certainly not to the level that would withstand the scrutiny of a BOE MRE audit or somebody else taking a real good look at the program. For those facilities, there's a lot to do by November 15th. So whether you've got a program already that you've been addressing to be good to your employees, good to the environment, and good to your business interests too, or if you've been have a very robust program, you want to look for these gaps and make sure that you fill in the gaps and make any improvements that are necessary. The key thing to keep in mind is the bulk of these elements are common to other loss prevention programs. So if you're a company that's got onshore and offshore resources, your onshore business unit may already have a lot of the bases for these programs where there are minimal differences between SEMS, PSM, and R&P. Offshore facility companies that also operate onshore facilities can also tap into resources and technology. You may have people on, even though risk management professionals are engineering contractors that support these programs, if you've got offshore and onshore operating arms, you may have a lot of resources internally that you can tap into as long as you understand what the differences are and address those gaps to beef up your SEMS program. Okay, next slide. So what represents generally good strategies? Recognize SEMS encompasses a broad spectrum of activities. You want to integrate, minimize duplication, recognize there are similar objectives for all these performance-based SMS requirements. Use the program overlaps to minimize duplication. If you can have one incident investigation procedure that covers the bulk of the issues for PSM, R&P, and SEMS programs, great. The more you can make things common, that minimizes the training needs for personnel when you transition from one facility to the next. Working towards a unified program, it can't be 100% unified because there are differences in requirements, but a lot of the core issues, if you can unify them, it can greatly simplify your implementation of all these regulatory programs. Another recommendation is start simple. Take your existing elements and weave it into your new program. Look at what you've got. Do a gap analysis. See if you've covered all the issues or if there are pieces missing that you need to address. And then, of course, then update it. Also, November 15th, again, is rapidly approaching. I would not wait too long. Internal resources or external contractors, if the BOE MRE keeps that November 15th deadline and doesn't extend it, everybody's going to have a lot to do, and a lot of the good people and good resources are going to become pretty scarce at some point. Next. Okay, also something to keep in mind, gosh, it's the 21st century. It is 2011. Offshore facilities can really benefit from a lot of the contemporary communications and information management approaches. A lot of this is because resources are often at onshore locations that are remote to the offshore facility. So you've got to have a better ability than most. The need to share information and to cross-pollinate this stuff is more acute for offshore facilities than it is for onshore facilities. An onshore facility, like a major refinery, can have basically an office at the plant site and almost a room where everybody goes and does their thing and looks at paper documents. That's not even conceivable for most offshore facilities where you've got resources onshore and personnel offshore that needs those resources. Responsible individuals are also more likely for offshore facilities to be addressing multiple facilities. Again, a need to optimize efficiency and sharing of information. And that information needs to be shared with a corporate location in many cases, many other individuals, and of course, multiple physical locations. So a lot of people are going towards web-based software and internet communications that can facilitate SEMS application. There are several packages coming on the market. SEMS Solution is one of those that Risk Management Professionals puts out. And if anybody needs any information on that, you can call basically anybody at the office. So what I wanted to do is try to identify the correlation between these programs and identify mechanisms for how to implement them effectively. There's a lot more information in the paper that's going to be sent out. And also, if you need additional background information, this is just a slide with some recent webinars that we've done, and we're trying to address all the different elements that are part of the SEMS program. We've been hitting those lately, and there's a lot of background information provided for all these different regulations in the 2010 series. So I'd encourage you to go ahead and log on, get on our website, take a look at these. I think they'll be very helpful training material. I hope they'll be very helpful training materials for you and if you need to get other people up to speed in your company. Again, we do this because we are engineering contractors in this area. We want to make sure our own people are up to speed, trained, and share information. And we like to make sure we provide that outreach also to other people in the offshore industry. Like I mentioned, there's a lot to do by November 15th, and the more people that have the information and can make use of it, the better. And before I make myself available for questions, I just want to let you know the next webinar that we've got on sensible operating procedures is coming up on March 29th, same time, although it'll be daylight savings time at that point, 10 a.m. Central and 8 p.m. Pacific time. And before I take questions, another little reminder is, oh, next slide, please. Oh, you know what? I skipped a slide. I'm sorry. Backing up a step, everybody's looking at the screen on our recent webinars that you can tap into from off of our website. And next slide, please. Okay, our next webinar is on March 29th. Why don't you back up, Solveig? Okay, this is our next webinar on March 29th, and it's on sensible operating procedures. Next slide, please. Okay, so before I was going to remind you guys, the MMS 131 sheets on OCS performance measures, those forms are due on March 31st, and they're in Appendix 1 on the SEMS program requirements. If you have any questions, just call any of us at the office. So at this point, I will open it up for questions, and I can take those either verbally or they can be provided via your chat window. Okay, all right. In that case, it looks like everybody's pretty well set. Any follow-ups? You've got the number on your screen. Feel free to call, and happy to help out. And thank you for attending our webinar this morning.